crew, so we're going to start by multiplying fractions today. Finally, you are over all of the torture of adding and subtracting fractions. I hope you'll find this to be a little bit easier. So let's start right away with 3/4 times 5/6. Now, the good thing about multiplying fractions is you don't have to find common denominators, so we don't have to go through that. And we do line them up side by side like this. So when you're multiplying fractions, all you have to do is multiply across the numerators and across the denominators, and you're done. So let's do 3 times 5 is 15, 4 times 6 is 24. Now you do have to reduce, so you think what number goes into both, 15 and 24. I know 3 goes into both, so I'm going to, what you do to the top, you do to the bottom. 15 goes into 3 5 times, and 3 goes into 24. I'm sorry, I meant 15 divided by 3 is 5. 24 divided by 3 is 8. This can't be reduced any further, so this is lowest terms. Now hold on, I'm going to show you a trick, a shortcut. I want you to have a good attitude about this shortcut, because really it's going to make your life much easier when these fractions are really big numbers. Trust me. Now it's called cross-reducing, and even your book is teaching it, so I'm going to make sure we try this out. And I like to think of it as these are the crosses. Those are little arrows I'm drawing. Instead of reducing numerators and denominators, we're going to go across to reduce. So we're going to look at the 3 and the 6. Can we reduce these two numbers? Is there a number that goes into both 3 and 6? Well, yeah, 3. 3 goes into both, so watch this. 3 goes into 3 one time, and 3 goes into 6 2 times. Did you see how I did that? Now, is there anything that can be reduced with any number that goes into both 4 and 5 evenly? No. So you can't cross-reduce those. Well, what I have left with is a 1 for the numerator, a 4 for the denominator, a 5 for the numerator, and a 2 for the denominator. Now, you may be thinking, but it looks top-heavy. Well, it doesn't matter, because now we're going to multiply. So let's watch. We're going to go across to multiply, just like before. And our answer would be 1 times 5 is 5, and 4 times 2 is 8. Voila! See? It is the same answer. All you get to skip is reducing in the answer. Now, it also really helps when you have really large numbers and you don't want to be multiplying large numbers and they're harder to reduce. So hopefully we'll come across another problem where we'll do that. That is called cross-reducing. Great shortcut, especially those who like to avoid big multiplication. Let's try our next kind of problem. It is when you multiply a whole number times a fraction. 1/5. So you can't multiply a whole number times a fraction. You have to turn the whole number into a fraction. So this is really actually pretty simple. All you do is put this number over 1. Look at it, it's improper. If I were to fix this, I would divide the 1 into the 13 and would go evenly 13 times. I'd be back to my whole number. So I'm not changing the value, I'm just making it into temporarily a fraction. Now I can go ahead and multiply. Oh, I should check. Is there any cross-reducing? No, there's nothing that goes into 13 and 5 evenly. So, and the 1s are already as low as they could be. Couldn't be any easier to multiply. 13 times 1 is 13, and 5 times 1 is 5. Now, you can't leave it like this. I know you remember this. This is improper. We have to turn it into a mixed number. So what you do is you divide 13 by 5, and it goes in 2 times. Because you know that 2 times 5 is 10. How many are left over? 3 are left over, that's the remainder, and you just bring over the original denominator. If you've forgotten how to do this, go back and review improper fractions and mixed numbers. I did a video on this. This, folks, is reduced to lowest terms. The 3/5 is reduced, so that's our final answer. Not too bad, right? All right, well, they get a little bit more complicated. Let's try. So let's say I have 1/3 times 1/4 times 2/3. You're going to have some of these where you have multiple fractions that you have to multiply together. Now we're going to do a couple numbers at a time. So here we go. We're going to start with 3 times 4 is 12. So you think to yourself, 3 times 4 is 12. And then I'm going to just multiply the last 3 times 3. So 12 times 3 is 36. So our denominator would be 36. Now the top numbers are easy to multiply. 1 times 1 is 1. 1 times 2 is 2. And I left it just like that. Can't leave the number this way though. I have to reduce to lowest terms. So what I would do is I know 2 goes into both of these. So 2 goes into the top. What you do to the top, you do to the bottom. 2 goes into 2 once, and 2 goes into 36. Now if you have to, come over and do chicken scratch. You will do a lot of chicken scratch when we're doing these kinds of problems. Let me show you short division while I'm here. So 2 goes into 3 one time. There was 1 left over. So instead of subtracting down here, I'm going to put it right there with the 6. Now 2 goes into 16 8 times. Goes in evenly. That's the same as if I would have worked it out. So you try working it out and you'll see it's the same answer. So 1/18. This is lowest terms. I can't reduce any further. That's your final answer. So more fractions just means you keep multiplying across. The last kind I want to show you is a little bit different. They have 1/2 take away 4/8, and it has a bracket around it like this. And then it has times 3/7. Well, in this one, let's remember order of operations. You have to do what's inside the parentheses first. And I know you're looking at this problem going, great, back to subtraction and back to unlike denominators. So yes, we have to stack them. This is good. It makes you practice. You're never over with those adding and subtracting, are you? So let's fix this before we can solve it. So I know I could see it right away. The common denominator is one that's already there. It's 8 because they're in each other's times tables. So this fraction I didn't have to change at all. The top one I did. So 2 times what gave me 8? 2 times 4. So what you do to the top, you do to the bottom, and vice versa. So that would be 4. Whoa, look at this problem. 4/8 take away 4/8. Guess what that equals up to? Absolutely nothing. So, interesting problem here. What I have in the parentheses is 0. If I rewrite this, it would be 0 times 3/7. Well, what would that equal out to be? 0 times anything is 0. Well, there you go. I guess it was easier after all. Folks, that was 4 different ways to do these kinds of problems. We learned about cross-reducing. I hope you can try that on your homework. And be sure to ask lots of questions in class if you're stuck.